Yeah. So do we have everyone now, or are we missing? You're here, Ray? Yeah. Are we missing Sabrina? Yes, okay. Is she at GNIB or something? Or?
No, she's
sick?
Well.
Okay, yeah. Right. So the good news is that's for semester 1, that was the calculus chapter finished, and the last chapter we have to look at in semester 1 is pretty easy. It's just some basic probability. Not advanced stuff. For what?
Maths.
No. No. We are about to begin the final semester 1 chapter, which is probability.
Oh, that's easy.
That's what I'm saying. Thank you. So, the first lesson in the probability chapter is all about something called sample spaces. Now, I should point out, you're all science students as a minimum, and most of you are also medicine students as well. So, this is actually an important chapter for all of you, because it doesn't really matter if you're going on to do science or medicine or whatever. Everybody will need this either now, or Charles entry test or IFY test, but also it's something you'll come back to in the future at your undergraduate studies at university. Okay, it's good if you can get the basic ideas well understood now. It'll make your life easier later. Okay, so I wonder if anybody here has heard of the term sample space, or knows what a sample space is. Maybe. Forgot.
I can't remember exactly.
You forgot too.
Yeah.
Anyone remember? No? No?
It's
more than just the size.
It could have 3 blue balls, it could have 4 green balls, but it's well known people will take 1 ball.
No, that's not really the sample space.
It's one space where
Yeah,
could be a lot of things that could be inside.
getting closer. Do you know?
So I'm thinking if you're picking from something,
Yeah.
like the
Yeah.
total number of things that you
Oh, close, yeah, because that's what he was saying as well, the total number.
It's not close.
Yeah, okay, so I think some of you kind of nearly have it, but not quite. So, sample space is a space of all the possible outcomes that could happen for an event. So like if you consider, for example, the event, your grade in maths, for example, then the sample space, I'll just write SS sample space, is all the possible outcomes to that event, which would be A star, A, B, C, D, E, and U. Okay? Now, this particular example I did is a little bit complicated because it's not like each grade is equally likely. So a more simpler example might be something like taking the event, you flip a coin.
yeah.
That's a little bit more straightforward. The sample space here would be
Heads or tails.
heads or tails,
Which is 50-50.
which is just 2. Okay? Yeah. So like this is very conceptually, this is what a sample space is. So you could say the sample space is the space containing free samples for you to try at the supermarket before you purchase. Sample space is the space containing all possible outcomes to an event. Okay? So I think the coin example is the easiest one to See, the event is you're flipping a coin, and the sample space is heads or tails. Okay? Yeah. Now, we can use sample spaces to calculate probability as long as each outcome is equally likely. So, just the next, sorry, do you have that? So the next point is we can use sample spaces to calculate probabilities as long as each element in the SS is equally, two L's or one? Who cares? Equally likely. Okay. But before we even do that, we have to talk about what exactly probability means. So I'm sure this is a word you all know.
Yeah.
What do you know about probability? It's a chance, yeah, but what about its values? What do you know about its values? Yeah, you can have it as a fraction, or as a decimal, or as a percentage. But what's its, its minimum value is? Minimum value is 0. Maximum value is
100.
1. 1. Okay? So, we can say probability. What letter do I usually use to represent probability? P. It's represented by P. A couple of things we can say about P. It's between 0 and 1. And what's the meaning of each? If a probability has a value of 0, what do we say about the outcome? Not possible. It'll never happen. Okay? And a probability of 1? More than likely and more than almost. Must happen, yeah. Always happens. Okay? And then any number in between represents how likely or unlikely it is. So like an example would be if P equals 0.5, that means there's like a coin flip, a 50-50 chance of it happening. Okay, so if it was, we say that's a 50-50 chance. So obviously as we move towards 0 we get less likely, and we move towards 1 we get more likely. But I think we all understand this conceptually. Sometimes we can use percentages. So for example, 0.5 as a percent would be, who said 40? 0.5 as a percent would be 50. 1 as a percent? 100. And 0 as a percent? 0. Okay. Now, before we just finish talking about values of probability, there is another way to measure chance. We can use a probability, a decimal or a fraction. Yeah, actually, I didn't say with fraction. So like, you could say probability is 1 over 4. What percent?
25.
25%. Okay. There is another way to talk about probability. Does anyone know? Oh no, what I mean is another term, like the word probability. Yeah, but I mean it has a technical meaning. But you're right, it's a synonym. No, it has the same meaning as probability in the sense that it's a number. Look at you all. So innocent. You've never gone gambling before, no? No, nobody's ever placed a bet on a horse, no?
No.
Odds.
Ah.
Oh, yeah. Odds. Yeah. Does anybody know what the definition is of odds are? It's not quite the same as probability, you know?
What are the classes? No, like I mean, like if I said to you, for example, the odds are
2 to 1, or in other words, 2 over 1. Obviously, that doesn't have the same meaning as probability because we just said the maximum value is 1.
This is 2.
So, yeah, so this is, it can't have the same meaning.
So it's gonna be a thing. It will never happen.
Nope. Nope. No. No.
No, tell me the answer.
Come on, you don't need to pretend you've never gambled before. I won't tell anyone. Does anyone know? Does anyone know? Yeah, what would be the probability? You nearly have it there. It is something to do about being twice. No. Nice try though. Nice try. 2 over 3. So the way odds work is on the number on the top is in how many ways you could sort of win, and the number at the bottom is how many ways you could lose. So here is 3, because there's 3 different sort of outcomes, 2 wins and 1 loss. And we're saying in 2 of these situations we could win. So this is not as easy for you to deal with, which is good because we'll use this for our studies, okay? But I'm telling you this because, you know, if you're doing some reading of a journal article, okay, it would not be unusual for, you know, somebody in the abstract or in the paper to just casually mention odds instead of probabilities, just to make the reading a little bit more pleasant, you know. Like, I mean, you could say, oh, the probability of getting to the sea is 5% or whatever, you know. Or you could say, you know, 20 to 1. You know what I mean? Like, it just, for some people, this is easier to read than a percentage, but I don't think this is the case here. Yeah, okay. You would prefer to read it as a percentage, I'm sure. Yeah, okay, all right. Well, I'm telling you now, it is something just to keep in mind, that it is a word that you could see in a paper. I'm really thinking a medical paper where they talk about people's risk, you know, of getting a disease or something. They talk about the odds of getting a disease. 100 to 1, 1,000 to 1. Have you heard these terms before? Yeah. Yeah? Yeah. Okay. Right. Let's have a look at some examples now. Oh, and before we do, just the definition of the probability formula. So if you want to calculate the probability, in the denominator it's the total size of, the sample space, which is the number of possibilities. And on the top, does anyone know?
Something.
Correct. Yeah, what is it? The thing that we want, the required thing. The number of outcomes we want. Like you said, how many of the things that we want. Yeah. Let's have a look at some examples. You might want to write this down, this formula, although I think you probably all knew it. Yeah. Have you seen this before? Yeah.
I just remember that I don't think all these
Who? Yeah. Snuck in late, you see. Right, okay. Continue now. Let's have a look at an example. So, the event I want is a coin, 2 coins being thrown. Let's write down the sample space. So what's the sample space here? What's the first outcome we could possibly have? Heads followed by heads.
Yes. Tails followed by
Tails followed by heads. Heads followed by tails. And finally,
tails followed by tails.
Tails followed by tails. And let's suppose now I ask the question, what is the probability of getting the same face? So that is, you throw the 2 coins and you want them both to be the same. What would that be? A half, yeah, because it's 2, 1, 2 over 4. Fair enough? Yeah, okay, let's do another one. Right, I'll give you one to try, very straightforward as well. Can I scroll down? Yeah. So we have a bag, and it contains one red, one green, and one blue ball. And you take a ball out 3 times, but each time you take a ball out, you put it back in. No, you don't keep it in this one. Yeah. So what's the expression that we say in the question where we indicate that we're not keeping the ball and we put the ball back in? There's a particular phrase that you see in these questions. Yeah. Is this with or without replacement? Yeah, we say we do this with replacement, meaning each time we take the ball out, we put it back in and have another go. And we do this 3 times. First thing I want you to do is to write down the sample space. I'll give you the first one. You can start off with red, red, and red. Okay, off you go. See how quick you can do this. Actually, I should have shown you this earlier when I was talking about odds. It's my recent betting slip. I'm betting on who the next US president will be. So I'm just hoping it's not Trump. So I have a whole €2 on Joe Biden. That's who I'm going for.
It's definitely Trump.
Ah, no. Don't say things like that. It might come true. Ah, yeah. I usually do. The last bet I placed was who will be the next Prime Minister of the UK, which I bet on Boris Johnson. So I didn't want him to be Prime Minister, so I thought if he wins, I need some financial compensation just to help me through this difficult time. I saw it as a type of insurance policy, you know?
Very clever.
Yes. Yes, yeah. I really don't want Boris to be Prime Minister, but, you know. It's illegal? No, it's okay. Depends which country you're in. Right, how big is the sample space?
Too big.
Too big.
I got lost.
27. Yeah, okay, so let's have a look. So, red, green, red, blue. And then we switch the next one. So what's that? Red, green, red, green, red, green, blue. And then red, blue, green, red, blue. You confused me now. Blue, isn't it?
Yes.
Yeah. Now look, this is the second row is the same, except the first one now becomes green.
Can't you multiply?
And then the other two are the same as everything up here. So it goes green, red, green, red, blue.
Can't you
And then the last one? Yeah, I want to list all the outcomes though. And the last one, the only difference is the first one will be blue, but then the next two will be the same. So it'll be blue, red, red, blue, red, green, blue, red, blue. Okay? So my question now is, what's the probability that you get 2 and only 2 the same colour?
Okay.
So we know what's on the denominator. What is it?
27.
27. Okay? Let's count how many situations give us 2 colours the same. Now, exactly 2. The first one?
1.
No!
This is 3.
This is 3.
Second
Okay.
one.
1,
2.
2, 3, 4, 5, 6. Okay.
6 times 3.
Now, will it be 6 again in the next one? I kind of feel like it should be. So this first one is green, red, red. So that's one of them. Then the next one is green, red, green. Green, red, blue. Green, green, red. Triple green, no. Green, green, blue. Green, blue, red, no. Green, blue, green. And green, blue, blue. It's also 6. Okay, so we see a pattern here. The final row will also have 6. So in total, that's 18, which we can simplify down, right? What's that? 6 goes into that 3 times, isn't it? 2 over 3, 3 over... No, I don't... You're confusing me, man. 6...
Yeah, divide by 9. So you
2, thank you, over
2
3.
over 3.
Yes, you got it. Good job. Okay, write that one down.
Too difficult.
Probability is on the IFY exam, but it's also really common on any kind of medical entry exam. Doesn't matter where it is, Charles, the Brechin, whatever. You've got you're pretty certain to get a probability question on a medical entrance exam, you know, and it's usually, they usually do something with like childbirth or something, you know, like you know, what's the probability of having 3 boys among 4 children or something like that, you know, this type of stuff. And genetics doesn't come up on the entry test, but you'll do some probabilities with column in the second semester on genetics. And it's the same concept. You list out all the outcomes and you count how many you want. You know, so like, what is it? You can have, like, for example, like A and A, small, like this, isn't it?
Yeah.
And you might say, what's the probability that the trait manifests itself, that it's shown? So it would be, I don't know, like 3 over 4 or something? Or
Something.
if they have the dominant gene, yeah. The only time it doesn't manifest is if there's 2 recessive ones, perhaps, yeah. You know, so, I mean, there's no escaping this topic in a medical science context. Yeah? Okay. Let me give you one to try. Can I scroll down? Yeah. I'm going to give you one that was on the Charles exam, and also one that could be on the IFY exam, and it's kind of a classic type of problem as well, so it's something that you will see again. So the event is to roll 2 dice. Okay, so the first question I want is the sample space, and the second question is I want the probability that you get a score which is greater than or equal to 8, and the score is defined as the sum of the 2. So for example, if you roll a 6 and a 6, you say your score is 12, and you roll a 1 and a 1, you say your score is 2. Okay. Now, for this sample space, you can list it out like 1, 1, 1, 2, etc. But what is far more common to do, and I'll get a start for you, is to put it in a table form, where die 1 is 1, 2, 3, 4, 5, 6, and die 2 is 1, 2, 3, 4, 5, 6. And everything here is the sample space, so the first one is 1, 1. it helps you keep track of all the possibilities. Okay? Right, give that a go. Give that a try now. Good job, yeah. So now you're counting up. Yeah. Now you can include 8. It's greater than or equal 8.
Oh.
So you can count that 8s there, yeah. Yeah. Got that? Yeah. What you get? Simplified down. Yeah.
42%.
That's about 42%, isn't it? Yeah, it's a little less than half. Do any of you guys watch the impeachment? Or that's
Impeachment talk?
not so? Yeah, not so interesting.
I only see like
The headlines.
Yeah, or
Yeah.
after certain events.
Before Trump was elected,
Mm.
I had a chance, and I never did it, and now I regret it, to place a €2 bet before Trump was elected. The bet was Trump will be elected, but he will be impeached.
Mm.
And I didn't. And do you know what I would have won? Would have won blooming €100. So I'm annoyed now that I didn't do that. It was Trump to win and then be impeached in his first term.
It seems likely.
I know, but they were paying €100 for €2.
Hmm.
So I'm like, rats. I missed that. So, oh well. But you're right. It did seem a bit odd to me because it did seem like a likely outcome, you know? Huh? I know, yes. This is why, you know, I was thinking of it. But, oh well. Sometimes you get it and sometimes you don't.
I have a feeling he won't get impeached in the end.
No, he will be impeached, but the question is, will he be kicked out of office?
Exactly.
Yeah, I don't think he'll be kicked out of office, but I think he will be impeached. Okay, so we have to count how many of these boxes. What's that? Well, you know the what's it called, the Senate or the House. One of them first votes to impeach, which means then the next House decides sort of if there's any punishment, like what's the consequence, you know. So, like being impeached is like saying you're found guilty, but then the next House votes on what the punishment is. Since the upper house is controlled by Republicans, it's unlikely that they'll vote to kick him out.
Yeah.
But the lower house is controlled by Democrats, so they will vote to impeach him. But it's not likely to be any consequence.
Is it just like the no trust vote in the UK Parliament?
Like what?
The no trust vote.
It is like that, yeah. Yeah, except the difference is in the UK one, if there's a vote of no trust, it automatically triggers the government to look for a replacement. It's not the case in the US. Yeah. Okay. Which of these boxes have a score of more than or equal to 8? Is there any on the first row? No. The second one? This one, isn't it?
Mm-hmm.
Oh, so it's going to look like this, isn't it?
Yeah. Right angle.
Right angle triangle, yeah. Yeah?
Yes.
Mm-hmm.
Yeah.
No, I've
No,
done one too many, haven't I?
Yeah.
Yes.
What's gone wrong?
Uh,
Oh, that's right. No, it's not perfect. Oh, it is, I'm
it
finished.
is, yeah.
There's nothing here. I was continuing too much. Right, how many is here?
15.
So it's 15 over
36.
36, which you said as a percent is 42. 41 points.
6, 7.
42.
Okay, I think, if this was an MCQ, they'd probably round it to 42 if you had a choice here. Okay. Right, not too difficult, right? Fairly straightforward. So because these are so easy, I want you to try all of these. They're straightforward. Yep. So homework, which you can start now, is question 1 to 15. Oh, come on. They're easy peasy. Get started.
The entire page.
Correct. I'm toughening you up. Come on. I forgot. Who do we say was missing? No, Sabrina, yes, she was sick, yeah.
So, can we show our sample spaces in the table like that?
Yeah, I'm really supposed to have written down 1, 1, 1, 2. I should have, yeah. Yeah. Okay, let me just close this 1 second.
Or is it we need to show it in the bracket?
No.